In the given problem, one of the IP address is given. From that, you will have to find out the number of addresses in the block. Means in this network block, how many number of addresses you can allocate. The first address and the last address you will have to identify from that block. Since we have 73.22.17.25, this IP address is there. This one of the IP address where the first byte is 73. So here it is in between 0 to 127. Therefore, this address is belonging to class A. And the value of n is class, everybody knows it is here, that is 8. N is equal to 8. It is interpreting here the number of network bits into the IP address are 8. And based on that, then you are using this n value for computing the number of addresses. So the number of addresses in the block, that is capital N, is equal to 2 raised to 32 minus n. This interprets 2 raised to 32 minus 8 is equal to 2 raised to 24. And this figure is coming like this way. So these many number of blocks, you can design it into your connections. To find the first address, we have the steps for extracting the information from the given address, and we keep the leftmost 8 bits as it is. Since n is 8, so 8 bits will be as it is, and the remaining 32 minus n, that is 24 bits, will be 0. So look at the IP address 73.22.17.25. In this IP address, the first 8 bit, keep it as it is, and the remaining 1, 2, 3, 24 bits, convert it to 0. So therefore the first address is 73.0.0.0/8, in which 8 is the n value. Means what? 8 number of ones you can have it into this. First 8 bits are used to specify the network address. That's it. And the remaining will be 0. If I would have been here /16, then my answer will be 73.22.0.0. Means 2 bytes will be enabled, other bytes will be 0. So remember, with this phenomenon here, you are writing the first address. And every time the first address is the network address which cannot be assigned to your machine. Why? Because through this network address, you are basically identifying the machine where to route the specific packet. To find the last address, exactly same step. We keep the left 8most bits, but instead of setting it to 0, you are setting the remaining 24 bits to 1. And therefore, you people come again here, 73.22.17.25. In this IP address, take 73 first byte as it is, remaining 24 bit 1, 2, 3, all convert it to 1. Means here 8 bit 1, 8 bit 1, 8 bit 1. So all this will be written as a 255.255.255. Obviously, everybody have seen how this 1, 1, 1, 1, 1, 1, 1, 1. These 8 bits, if you are converting it to 1, so it will be calculated by binary to decimal value, and answer is 255. So that you are doing it here. You are writing instead of 22.17.25, all these bits will be converted to 1. So here 8 number of 1, 8 number of 1, 8 number of 1. And after converting it into the decimal, you are getting the value 255.255.255. After that, here you are having the network designing diagram, and that generally can be shown in this kind of way, where the network address is 73.0.0.0 and the broadcasting address is 73.255.255.255. And the remaining machines will carry here the in between IP addresses, that is 0.1 to 255.254. These IP addresses will be there in the block. And with this specification here, then you can write down here the number of IPs set up into the network. So in a given network here, these many addresses can be allocated, and these addresses is the number, this 73.0.0.1 to 73.255.255.254. This will be, these many number of addresses are there, 16777 These many addresses you people are calculating it. The second category in IP addressing is classless addressing. There is no fixed criteria for finding the number of network bits, that is N, prefix length. You talk about the first part, that is N prefix, and 32 minus N, that is suffix. So in this here, this prefix is not fixed. Then you can get variations into that value. So that is called as a classless addressing. You are having a variable addressing techniques into this case. So you are having the first byte dot, second byte dot, third byte dot, fourth byte slash n. So this slash notation is also called as CIDR notation, that is classless interdomain routing notation. Why it is called as a classless interdomain routing notation? If you are having any packet to be transmitted from machine A to machine B, then here you may have two different paths can be there, A, C, B. Otherwise, you can have A, X, Y, B. So take an example. If you have a path A, C, B, otherwise A, X, Y, B. In such a case, here, this particular IP address notation is finding here where to route the path, and that can be identified by this N value. It identifies here the network path to which interface you supposed to transmit the data packet. So that's why this N value may be different. You mentioned that in class A, so many IP addresses are getting wasted. Class B, so many IP addresses are getting wasted. Again, class C, you have a IP address set up, but very small, means only 256 machines can be set up in one network. Like this way, multiple networks can be designed, but here there may be certain companies which may have more than 256 number of machines can be there. So therefore here, these variations can be identified. So you can have a /8, /12, /24, /27, /30, /4, etc. So this N value may be different, and it is called as a classless addressing technique. While defining this classless addressing, then you need to identify here one of the criteria called as a network mask. Wherever it is classful or classless, still you need to find out the network mask. When you are destining the packet to the specific machine, then here to find out the path towards the destination machine, the network layer takes care of here network mask. Instead of finding here the exact host IP address, it finds here the network address and its mask, and from that here it finds the interface where to channelize the packet. So for that particular purpose here network mask is used. Now coming to the point class A. First, class A, you are having n is equal to 8. What do you mean by n? N indicates prefix value. What is the n? N indicates the network bits. So this means here this prefix value or network bits has to be 1. So in class A, only 8 number of bits will be 1. And as you already told, 1111, the decimal interpretation of is 255. So then 255.0.0.0, this will be the network mask of your this class A. Come to the class B, n is equal to 16. 16 number of bits are 1. So see, these are the 16 ones are there. Converting it into the decimal value, you get it 255.255.0.0. So this is the network mask for class B. Come to the class C. First 8 bit, second 8 bit, third 8 bit, like this way 24 bits are there, which is used in for the prefix value. That means here you do have it here, the number of network bits 24 and all bits will be 1. Please students understand, the network bits always will be 1. The prefix value always will be 1. So whether it is variable or whether it is based on the class, still it will be 1. So come to the point here, this class C will carry the network mask 255.255.255.0. This way you can specify here the IP network mask into the network. 3-level addressing. Like in the telephone department, you must have seen here the telephone numbers are divided into some sections. You are having the STD code, you are having the area code, city code, then connection number. Like this way, the telephone number can have a bifurcation of identifying the number. So exactly same concept is there into the networking also. You may have a 3-level addressing or subnetting, in which here you are having three number of levels can be generated from the network mask. You said the prefix value n is constant into the classful addressing, but in the variable addressing it can be different. So how it can be different and how you can make the adjustment into the classes, that has been shown into this particular diagram. You can see here n number of bits are there, which is representing number of network bits. 32 minus n, which is representing the number of host I bits, that is the host ID. In classful addressing, this is the fixed, that is the length of net ID is a fixed. But in classless, you can have a variations into that. As well here, you can have the adjustment into this classful addressing also in this kind of way, where you can borrow certain number of host bits for the network bits. See the situation, you can borrow certain number of host bits into the network bits, means you can increase the number of network bits. This concept is called as a subnetting. This concept is called as a subnetting, means what, this will be the nj, and then 32 minus nj will be, or ni will be the number of bits for this host id which you people are having. This subnetting means what, dividing one network into multiple network, dividing one network into multiple network. Take the exact reverse situation. If instead of taking this increasing subnet id, if you are increasing host id, means you are minimizing net id and increasing the host id, then that situation is called as a supernetting. That situation is called as a supernetting, and you can find out the addresses accordingly. In these classful addressing, when we divide here a network to S number of subnetworks, to S number of subnetworks, each of equal number of hosts, then the number of network bits in each subnet can be calculated. N sub is equal to n plus log of S to the base 2, in which here you are having n is the number of network bits, n sub is the length of your subnet id that you are going to identify, and s the number of subnets, which must be the power of 2. If you have been given here 10 machines And in 10 machines it is ask you to partition it into the two network. Okay, partition it into the two network. Then 2 is the power of 2. Yes, I ask partition in two different network, so that 2 value is the power of 2, so it is adjusted. Fine. I told you that I have a 20 machines, partition it into the three department. I want three different LAN for that 20 machine. Is it possible? No. Why? Because see, the S number of subnets always should be the power of 2. And I am telling S is equal to 3. It is not in the power of 2. So if I will take the power of 2, that is 2 raised to 1, 2. I cannot satisfy the condition. Yes, 2 raised to 2, that is, sorry, 2 raised to 1 if I am taking, then I cannot satisfy the condition. And 2 raised to 2 means what? 4. Yes, I can design 3. 1 can be extra. So this way here, you can use the network partitions. You can divide one network into the multiple network. Take an example here, you do have it. The given IP address 172.16.0.0/25. Find the number of subnets, the number of hosts per subnet. Also for the first subnet block, find the subnet address, first host address, last host ID, and broadcast address, etc. So come to the point again. Take the IP address 172.16.0.0. Since the given IP address is in between 128 to 191. Since the given IP address is in between 128 to 191, therefore this IP address, this network address is belonging to class B, and therefore you are having n is equal to 16. Everybody knows that n is equal to 16 for class B. Therefore the total number of subnets, so the class B address, so the number of subnets can be calculated 2 raised to 25 minus 16. Why 25? Because 25 number of network bits has been given, minus 16 number of bits, that is for host ID which you are having, and then here you are getting 2 raised to 9, that is 512 number of machines can be designed in your network. 25 minus 16, you are doing it for calculating here the number of machines into the network. So capital N basically you are calculating here, and then you are finding here the capital N with the help of this formula. Number of hosts per subnet is equal to, that is capital N sub, 2 raised to 32 minus 25. Since slash 25 means what? N is equal to 25. N is equal to 25, that is net ID. The number of network bits in the given network is 25. So 32 minus 25, 2 raised to 7. That means 128 number of IP address you are having it into the network. This way here you can calculate here these 128 number of machines in each network you can have it. So therefore the first block you can have it if you telling that this is this particular IP address you are having, that is which is here the initial address, network address, then 172.16.0.0, this will be here your subnet address for the first block. Then you are having here broadcast address 172.16.0.128. Why? See, 128 machines you are connecting, 128 machines you are connecting. So in such a case here, when you will move from 0 to 127, you will be able to connect here 127 number of machines, and up to 128 you want it to be connected. So like this way here, this IP address can be 0 to 127. So like this way here, you can basically connect here 128 number of machines. So this will be the last and net broadcast address 127. From 0.1 you can have a first address, and 0.126 tak you can have a last address. Why? Because this network address and broadcast address, you cannot assign it to any machine. You cannot assign it to any machine. It should be fixed for broadcasting purpose and defining the network to channelize the packet to the specific route. See here, there is another problem which is depends on the classless addressing technique. It is regarding here the subnetting. The problem has been given: an organization is granted the block 132.34.12.64/26. The organization needs 4 subnetworks, each equal number of hosts. Design the subnetwork and find the information about each network. With this specification here, you will have to calculate the specific number of machines into the subnet and its IP setup into the network design.